This question is on the topic of direct and inverse proportion. It's quite an important question, and the presentation has to be quite precise, so I will try to be as accurate as possible. Okay, the question states that y is directly proportional to x squared, which means you can write the equation y equals to kx squared, where k is a constant. Okay, you have to be a bit familiar with the difference between a variable and a constant. So, like in an equation, y equals to 3x plus 2. Okay, y and x are variables, right? The value of y depends on the value of x. X can be any number. You can substitute x with 2, for example, okay, and then y will be determined accordingly. Y will be 8 in this case. So y and x are constantly changing. So that's why they're known as variables. The numbers 3 and 2, they are constants, okay? So in these kind of scenarios, it's quite easy to differentiate variables and constants because they look quite different, right? Variables are represented by letters, constants are represented by numbers. But in this case, y, k, and x are all letters, but only y and x are variables. Okay, k is a constant. So how do we interpret this? K is just a number, it's a fixed number, but we don't know what it is yet. Okay, we can try to solve for it, or if it's not necessary, we can just try to think of it as a fixed number that we do not know. Okay. Okay, the question then states that y equals to a for a particular value of x. So some people will be tempted to write a equals to kx squared. This is actually wrong because this statement says that a is equivalent to kx squared for all values of x. Remember, x is a variable, which means you can substitute any value in there. But this is not true. The question states y equals to a only for a particular value of x. By the way, a here is a constant. So y takes on a fixed number for a particular value of x. I think it'll be easier to see if this particular value of x, if the question stated that the particular value of x is 3. Okay? So y will only be a when x is 3. So obviously this statement is wrong, right? This statement would be correct, right? When y is a, x is 3. Okay? Y is not a for every single value of x, only when it's 3. But we can actually skip this step, right? There's a method that will not require you to write this step. So in order to avoid confusion, we can just skip it entirely, right? Find an expression for y in terms of a when this value of x is doubled. Okay, so instead of finding out what k is so that we can double x and then find the new value of y, right? We can let z be k 2x squared instead. Okay, just think of this as I think a suitable analogy will be where y is like Tom's weight. Okay, and then x is one crate of food. So Tom's weight is uh, related to a crate of food through this equation, right? K times x squared. Whatever amount of food you put inside the crate, you will square that amount, and then you times k. That will give you Tom's weight, right? Now we want to define z as Peter's weight. Okay, so instead of giving Peter one crate of food, right? Now we give Peter 2 crates of food. That's double of whatever food we are giving to Tom. So that Peter's weight will represent Tom's weight if we double his food. You get the idea? So we find Peter's weight, and then if you expand this, you'll see that 2x squared, the square belongs to both terms inside the brackets. So you'll get 4x squared in here, right? If you rearrange the terms, you can write the 4 at the side, 4kx squared. And you realize that the kx squared is the same as the kx squared up here, right? Which is equal to y. So z equals to 4y, or in other words, Peter's weight will be 4 times of Tom's weight. Okay? So they want to know what happens to Tom's weight, which was originally a, when we double his food, right? When we double x. So if we let Tom's weight be a, right? Substitute y equals to a. Then Peter's weight, okay, to make this clearer, you should actually always write this statement first, right? I mean, z equals to 4y. Just have this statement written out so it's clear, right? Then, sub Tom's weight as a, sub y equals to a, and you'll see that Peter's weight will just be 4 times of that, right? Peter represents what Tom will weigh if we double his food. So if Tom weighs a kg, then Peter weighs 4a. As simple as that. Just a word of caution, some people, instead of writing z equals to k 2x squared, they will just, maybe they'll write sub x equals to 2x, and then use back the original equation, y equals to k and then 2x squared. Now you can't write this because you see, you already define y as Tom's weights, and this is the equation through which it's related to one crate of food. Now you are saying again that Tom's weights is related to two crates of food through this equation, which is contradictory to your first statement, right? So that's why you cannot use y again. You got to use z, basically another person, right? You find Peter's weights and then find out how Peter is related to Tom, so that you don't contradict each other. First you say Tom gets one crate of food, then after that you say Tom gets two crates of food. It's not mathematically consistent.